you're going to be reacting a Grignard. Let me change up my Grignard now. You're going to be reacting your Grignard with an epoxide. Okay. This is an epoxide. And how do I know it's an epoxide? Anytime you have a carbon bonded to a carbon, and both those carbons, right? Both of those carbons, they connect to like an oxygen to the same oxygen, right? Kind of looks like a triangle with an O at the top, right? That's an epoxide. Okay. So notice that this epoxide is not symmetric because this side has this methyl group branching off, and this side has it's an empty space here, but basically there are two hydrogens here. We just don't show them. But notice that this right here is it's not symmetric. So this is a unsymmetric epoxide, right? Unsymmetric epoxide. So basically, whenever I have a Grignard in the presence of a unsymmetric epoxide, it's going to attack the less branchy side of the epoxide, right? So if I labeled this as A and B, which side would be less branchy?
B.
B, right? So your focus is going to be attacking this side, okay? So let's zoom in. So obviously we have to label this. So this is carbon 1, and then I have 2 chains branching off 1. So we'll call this 2 and we'll call this 3. So 1 will attack B. Okay, 1 will attack B. And then the next part is understanding that it's the B-O bond that's going to break. Okay, so the B-O bond is going to break. So this bond is going to break. Do not break this bond. Do not break that bond. Okay, it's the B-O bond. It's the B, which is considered the less substituted carbon, the less branchy carbon. It's that carbon-oxygen bond that's going to break. So that's going to give you this. Now, what I recommend is obviously drawing this part first, right? So I have my 1. My 1's attached to 2, and then that's attached to 3. So 1, right, bonded to B, right? Because what's happening? 1 is attacking B. So then this is the new bond right here. 1B, right? B is attached to A. B is attached to A, right? And then A is attached to, we can call this C, this carbon right here. C, right? And then remember, the B-O bond here broke, but the A-O bond didn't break. So we're going to draw an O here. Now that O is going to be negative because you broke this bond right here, you broke the BO bond, and then electrons got thrown onto O, right? Extra electrons, that's why it's negative. And then the step after that is known as a workup step, right? Workup, so it's like H2O workup. And in workup, you just turn O minus into OH. So this is my carbon 1, carbon 2, carbon 3, carbon B, carbon A, carbon C. This is your product. Does that make sense?
Yeah.
Perfect. Okay, so I'm getting